seems like we are live. I see people showing up. Hey, if you can see us, just drop a quick hello in the chat. I can see people are signing in. I am myself tuning in from India, New Delhi, and we also have Srinivasan, Sai Krishna in New Delhi, India as well. To know where you're all tuning in from. Just a quick show of hands. We'll just give this a minute or two to let people tune in before we get started. Nitesh says he's hi from Miami. Hey Nitesh. Hey, I remember you were tuning in yesterday's session as well. So it's good to see people joining TestMu on recurring basis from day one to day two. Good to see recurring uh, fellows joining the sessions. And there's here from Atlanta, USA. We have Nivedita from Atlanta as well. All right. So a good show of hands, and I think this is good enough for us to kickstart. And good morning, good afternoon, and good evening to everyone, and welcome to day two of TestMu Conference 2025. I'm Harshit Paul, Director of Product Marketing at Lambda Test, and I'll be your host for this session on testing the untestable, introducing agent testing. At Lambda Test, we have always asked ourselves, how do we go beyond traditional testing? And this question has led us to path-breaking innovation. Yesterday, we launched agent-to-agent testing, a platform that we have been building uh, to validate how you test AI agents. And today, we are extremely thrilled to lift the curtain and walk through its capabilities. And who better to walk us than the two leaders who live and breathe open source? Please join me in welcoming Srinivasan, Sekar, and Sai Krishna, both directors of engineering at Lambda Test, well-known open source contributors, and global voices who are pushing the future of testing forward. They'll take us behind the scenes on what we have been building and show you the power of agent-to-agent testing. So buckle up. This is going to be an exciting one. But before we get started, this session is recorded, and in case you need to drop off, you can find the full recording over your registered email address. You can also find this over AirMeet platform and also across Lambda's YouTube channel. And with that said, I welcome Srinivasan and Sai Krishna. Please take this ahead. Stage is yours.
Thanks, Harshit.
Thank you. Thank you, Harshit. Thank you so much for the very warm welcome. And hello, everyone. I see a lot of chats flowing in from different parts. So we are super excited to, talk about a lot of stuff today for the next 30 minutes.
Good morning, good afternoon, good evening, TestMu. Who test the agents? The question isn't just about a tagline. It's one of the most critical and urgent engineering challenge of our time. So we are living through a fundamental transition phase. For decades, software has been about automation, making predictable tasks faster. But now we enter the age of autonomy. So what is an AI agent?
See, basically, Srini, it's just not a chatbot, right? And AI agent is basically a system that can perceive its environment, make decisions, and take actions to achieve a very specific goal, right? It has basically three ingredients, right? One is a goal, a tool to act, and the reasoning to basically connect the two, right? And it's the difference between a calculator and a financial advisor, right? If I have to put it that way. And this new workflows is basically exploding, right? The 2024 Stanford AI index reports that the cost to train a large language model has sort of increased by over like 99% in just few years. I mean that's incredible, right? And this economic shift has unleashed an explosion of agentic AI, right? And I'm sure that we are seeing we are seeing this everywhere, right? Even there were so many talks in TestMu, or probably more lined up, where people are talking about agents, and things were all about LLMs, and then AI, then it's all about agents, and it's just not here. Everyone's talking about it, and everyone's like talking, and also seeing that how these agents can basically help and do a lot of these tasks, right? So definitely we are seeing them sort of everywhere.
Yeah, as you said, agents are everywhere.
Yeah.
So there are a lot of different kinds of agents.
Yeah.
Let's start with task-specific agent. Uh, I mean, starting with Devin, which create a lot of curiosity in the community, and AI software engineer. And there are a lot of agents that can book complex travel itineraries for us, right? So there are a lot of coding agents, for example, Cursor, Windsor, and a lot more. We have extensions for now, right? Klein and Rue, which is doing a wonderful job in terms of accomplishing coding tasks for our developers, right? So there is another kind of agent called platform agents. These are integrations to tools that we use day in, day out. So one of the famous agent is Microsoft Copilot. And we have agents embedded in Notion. We have agents embedded in Slack. That is something that we use day in, day out for our official communications.
So it's everywhere.
Yeah, it's everywhere. So there are also autonomous system agents. So these are the agents wherein it could help you to do scientific research, and these agents helps to discover complex chemical components, and in particular in logistics, it helps in managing workforce, inventories, and everything. So they are becoming the new kind of an application layer. There was an era we were building applications for humans. Now the data is consumed and we started building agents. So we are starting building our applications for agents. Like for example, Perplexity, which starts consuming a lot of data. It gives us precise information. So we started building our applications for AI agents as well now. This power brings in new challenges and risk at the same time when we build. And failures from these kind of AI agents in production impose a lot of risk, and they are no longer just simple bugs, for example. So these failures often create damage public reputation, often public deeply damages the trust of the user of an organization.
I mean, I can reckon that. And also, have you come across any such kind of real world scenarios where, agents are in place and probably something's really gone really wrong? Have you come across anything as such in real world?
Yeah, let's talk about some of the real world examples. In early 2024, a customer service agent was tricked by a customer for a major delivery firm. The customer service agent was asked by a customer about writing an haiku, how useless the application of the company was, right? So the answer from the customer service agent went viral. Although it is humorous, it brings in a lot of reputational damage for the customer. Right? Because it evidently shows to the customers that how exactly it lacked a lot of guardrails during the process of putting it in production. These are something that we haven't eventually coded and introduced. These are something about the reasoning of these agents that are deployed in production, and lack of observability and lack of testing and lack of feedback that we derive from these agents. And more recently as well, in March, and popular airline chatbot agent incorrectly promised a customer about a bereavement discount, which eventually had a reputational damage for them. And this promise from the airline was later forced by a tribunal to honor whatever they have actually made. The chatbot hallucinated about a policy of this airline which doesn't exist, and they had eventually faced financial consequences due to this.
I mean, this clearly is not a very edge case, right? For a system, and I can clearly see these are pretty straightforward scenarios, and they are not like super edge case or edgy edge cases, right? And I can clearly see that these are symptoms to a deeper problem, right? Because we are building systems with emergent behaviors, capabilities, and of course the flaws that were not explicitly programmed, right? I mean, we don't want to put flaws into when we write our programming intentionally, and we have seen that with agents, because they can misinterpret contexts, they can manipulate, and they can like sort of fail in ways that are entirely non-deterministic, right? And the one thing is I've seen is you can run the same test twice, uh, but you get two different results all the time, right? And this breaks the very foundation of a traditional quality assurances, right? And what's your take on that as well, right?
Yeah, the challenge is no longer about does the code work. The main challenge here is, can we trust the reasoning made by these LLMs behind the scenes of an agent? This can we trust the reasoning question has been our obsession of our engineering team for some time. So how do you systematically test an AI agent that thinks for itself, right? So you can't do an assert equals as like how you do it in the traditional applications, right? You can't do it with thousands of manually written test scenarios eventually. The solution requires a fundamental shift and the foundational thought process of our users and also for our QAs as well, right? So we have to build a system that could test not just for the correctness or completeness, but also for the competence.
Absolutely, Srini, because I mean, I think this is good stuff that you put out saying you assert is, you assert and assert equal. You can't do it that way, right? Because as any test that we write at whichever layer of the pyramid, generally what happens is we tend to write, assertions in your test where basically we say, your actual value and your expected value. But here it's slightly different in this world of agents because like I said, you're not going to get the same answer twice, exactly the same for the same question or for the same intent that we are trying to do, right? I mean, that's something where it's very different when it comes to agents and how you want to validate your agents, right? And I think that's what today we are going to, we'll be showing you. Is that kind of a system that we have built at a Lambda test, and we call that as Lambda test agent to agent testing. I think we have moved from writing rigid scripts to defining intent and evaluating outcomes. So let us show you the workflow. It's basically designed to be incredibly simple, a very incredibly simple, smooth flow. But the technology underneath is revolutionary. I think we have spoken enough about these agents, and we really see the problem there. I think with no delay, let's go ahead and see a Lambda test agent to agent testing in action and what we have built. Let's quickly jump into it and see a very quick demo of what we are doing. And as we show the demo, we will take you through what our agents are doing and how we are basically evaluating your agents. Are you ready?
Yes.
Sounds good. Okay, so this is how our landing screen is going to come. And if you folks are interested and you want to join, we are in beta. If you're interested and you want to join our beta, so you should see the link in the chat. So Harshit's going to put that, and you can sign up for beta, and we will reach to you. Okay. So the first thing that I'm going to do is I'm basically going to create an agent. So I'm going to name this as
so this is basically the agent under test. The agent under evaluation.
The agent under evaluation, right? So I'm basically called I'll just name it a shop agent, right? And we basically have different types of agents that you could basically test if it's a chat, a voice agent, or both. So for now, I'm going to basically create an agent, which is a chat, right? And with that said, there are two things that we can basically do. So you can, browse and upload your PRD documents into it. So basically, you need to tell Lambda test agent, hey, this is how my PRD is going to look like, because our agent needs to understand what does your system do, what it needs to validate, and things like that. This is not the only one way where you can, upload files. The files can be of your MD files, your PDFs, your videos, images, and things like that. And at the same time, we could also basically connect with different integrations like Confluence, Jira, and GitHubs. So where you might have your entire requirements in Confluence, so you could connect it to Confluence. Or you can also connect to Jira. You can connect to multiple things and basically ask our agent to fetch these kind of requirements from multiple sources that you have. Right. So let's go into that, and I'm going to basically browse, and I'm going to give it a requirement document. So I've just very quickly given a chatbot requirement into it, and I'm going to process. So Srini, what's happening behind the scene now?
Yeah, behind the scenes, we have quite a few multimodal agents that process these information. So the information can come from, as you rightly said, it could be a Confluence, for example. Let's say we have given a space, a name of the Confluence, and the page title of the Confluence. It could directly fetch the data from Confluence. It just doesn't just fetch it, it do a reasoning on top of it, and the Confluence page might have images, it might have several things embedded in it, right? So it can go in depth and analyze the data from different sources of data information that we have provided, right? So as soon as we feed in this data, our agents kicks in and process all of these information and make it ready, make it available for other agents to generate the scenarios.
Fantastic. So we already have an agent kicked in, and it can do a bunch of. It's already planned up what it needs to do, right? And so we have, like you see on the screen, we have multiple agents in place, ready to get into action. So as soon as you select what kind of agent you want to work on your bot, that's like, it could be a conversational flow agent. So I'll probably go with few of them for now. So I'm going to select conversational flow agent, maybe a context memory agent, and also a personality tone agent, very interesting, and a multi-turn reasoning agent, right? And let's go ahead and generate test. Now, behind the scene, so we have like 4 agents running, and these 4 agents in parallel are basically doing their job to create scenarios under these categories. That's a conversational flow and context memory, multi-turn reasoning agent, and personality. So they are basically creating scenarios for us based on the PRD documents or confluences, wherever the information has been restored, and they're creating as many scenarios as possible for us. And your scenarios would be available in a few minutes. So without waiting for this, so we have already generated few of these scenarios now. So we can quickly look into those scenarios and probably understand some of what kind of scenarios we have already generated and things, right? So I'll just go into another workflow that we have created. And like you see, we have multimodal interactions, intent recognition, and conversational flows. So we have those kind of scenarios already generated for us. So maybe we can just try to understand what these intent recognition or multimodal means to us, right?
Yeah. So let's talk about intent recognition agent, right? So it's kind of an agent. It has an ability to understand the actual user's goal or the purpose from their message. So let's say if a user inputs a message to an application under, the agent under test here, and the agent under test receives this message. Basically, user says, "I need to return back this T-shirt I have bought a couple of weeks back." Right? The agent is smart enough to understand it and identify the intent behind it. The intent exactly here is initiate product return, right? So what we are trying to validate the data, the expected response might be anything, but whether the intent is recognized or not. This specific agent is going to create scenarios about intent recognition. So a conversation might have so many intents within it. So let's say I ask about returning a product and also about policy, a particular policy, which is not related to return, which is completely different. So a turn in a conversation or in a dialogue can have multiple intents. Whether the agent under test is recognizing these intents from the user's message or not and responding appropriately or not is the validation criteria. So our agent is smart enough to provide what are the validation criteria, which basically derived from the PRD or the documentation that we have actually provided, or it could be a video conversation during the initial inception phase, for example. So it could derive all of these and then provides validation criteria for each of these scenarios. So that's about intent recognition. Let's talk about conversational flow. A conversation in logical world is nothing but a turn-by-turn dialogue between an under test agent and also the agent under test, right? A user to successfully complete a particular task. So let's, for example, a user asks, I would like to travel from a particular place to another place. And agent can respond saying, let's assume this as a travel booking agent, for example. Agent can respond saying, what is the date that you are looking forward to travel to? And let's say customer gives the user, here in our case, it is going to be Lambda test agent, which gives a response back to the agent under test saying, these are the dates, and can you give me probably fares of these dates? So agent is recognizing those intent within the conversation and gives me fares. And probably based on that, the Lambda test agent, depending upon the scenario it created, it can go ahead and share a proper date, or it could even drop the conversation there and then turn it to a different. Probably, let's say, if the agent doesn't give, Lambda test agent may generate frustrated response back, and whether the agent is recognizing the frustration and serves back the customer in a much more professional way or not. So I remember you have selected professional tone validation agent, right? So which also kicks in on those, I mean, those kind of scenarios kicks in on professional tone validation. You also asked about multimodal interaction. So this agent has the capacity to seamlessly understand, process, and also respond to the information that across various formats. A simple chat agent, for example, can have a conversation, and if for example, in an e-commerce world, it replies me back saying, let's say I search for a product through a chat interface, I mean chat agent. It replies me back saying, these are the images I have, do you want to select a particular? So it feeds in images. You can probably let's say you have a Netflix kind of agent wherein you need to feed in a video, right? So these are the multimodal interaction scenarios that agent can generate, Lambda test agent can generate depending upon the user's requirements. Again, the user can also feed in sample conversations as expectations that if there is a frustration, I would like to get the answers of this sort, right? A user can even upload a picture and get, get appropriate answers from agent.
And I think we just pick few to understand what kind of agents and
Yes.
what they basically do as well, right? I mean, if we can go into one of these scenarios to look through from a conversational flow aspect. So if you see here, I'll just quickly go into one of them. Yeah. So if you see, basically says what the user would typically enter for this specific test over here. I would like to return the blue V-neck T-shirt from order number blah blah blah, right? And we're checking certain validation points based on the requirements, and also what kind of expected response we would be getting, and things, right? So that way, so this is like an entire turn to turn conversation that we have, and you could basically give your bot curl and a kind of response schema that it looks, so that the Lambda test agent can understand that what's the other, who sits on the other side, and it can basically also talk to each other, get some responses from your bot, and try to evaluate your bot under test. And we've also had some test results which we already ran. And where do we run these tests? We run these tests under hyper execute, so you don't have to worry about anything. So we create the scenarios, we let the human in the loop over here as well, because you could go back and edit these scenarios, so there's a human in the
Maybe
loop as
add
well.
more validation.
Absolutely, you want to add more validations, you want to add more turns to it, you can feel free to do that as well. And then once you run and evaluate it into hyper execute, you would basically have your evaluation results, something that could look like this, right? So probably I'm going to take one of that, so that we could go and understand why the specific conversational flow, where it's going to talk about interaction repair after an agent misunderstands an order number. So you see the conversation which has happened between the Lambda test agent and the bot under test, right? And you see, from there are three categories that we have evaluated this specific scenario, and of course it failed. So if you go in all properties, you could see the reason also why it has failed, right? Probably we can pick one, the conversational completeness, right? So you could see that it did not fulfill the user's intention to cancel an order. Instead of processing the cancellation or acknowledging the provided order number, the LLM repeatedly asked for information that the user has already given, failing to address the user's request, right? So we also like sort of gave what was the reason for that specific category or that specific metrics to basically fail, so that you understand where you need to go improve your agent under test, and then you can make things better. And once you make things better, you come back and reevaluate. You don't have to regenerate the scenarios. You could basically reevaluate your bot under test, and our agent can take care and give you your new set of results, right? And similar way, there are multiple other things. If it's not a conversation, if it's, let's say, an intent recognition here from an evaluation aspect, so you could see multiple other metrics like answer relevancies, whether it's hallucinating, if there's biasness in this, and it's basically going to give you reasons for all these metrics failures as well over time, right? I think that's exactly what we wanted to share with you folks. And like I said, we are in beta. And if you are interested to give it a try, please sign up for beta, and we will get in touch with you on how we could try this.
Yeah, we have a lot more coming up as well in upcoming weeks. We are going to support multiple kinds of agents as well. not just voice. In case of audio, I mean, in case of voice agents, the conversation happened between an agent and a test and lambda test agent will also be shown in the audio format here currently. So we are going to support a lot more agents in the upcoming weeks. Stay tuned and do support and share your feedback. That helps us to improve our product as well.
Yeah, absolutely. And I think we are with 5 minutes in. I think we have 5 minutes, so probably we can take some Q&A. So I'll see if there's any Q&A for us. So I'm just going to look through that now. Okay. Yeah, it's a Q&A. Okay, cool. So let me do this part. Okay. So we have one here, Srini. So how can teams test early without ending up with results that don't reflect real world reliability?
Yeah, I think we can simulate quite a lot of conversations that we may not be able to generate it, right? So, I mean, again, human in the loop comes in picture, wherein you can add your own scenarios that you think that are really important, which agent currently may miss, and it also learns from the mistakes that it has done in the past. Again, when we test early and try to understand for several kinds of conversations that we may not think about, what would be the hallucination looks like, whether it is just focusing on completeness or correctness, or it is having some kind of bias, or it is giving me professional answers when I am frustrated, when I am interacting frustratedly. It is able to generate or identify the intents. So it is important to test early, and not just testing early. Once it is in production, it is also important to gather observability data of how your customers have used and feedback the knowledge back to our agents as well, which could derive more scenarios out of it and can iteratively improve as well in terms of metrics as well.
I think there's another very interesting question that I see here. Wouldn't this create a never-ending loop? Testing the agent, which is testing another agent. I mean, that's a very interesting question, right, Shubham? I mean, absolutely, and that's where how do you let one agent stop another other agent, right? And that's where if you see when we generate scenarios, we generate them upfront, so we know that for a scenario, this is the conversation that the bot's going to have, right? And even with a voice, we know when basically the conversation needs to end as well. So we take care of that, and I think that's the first question we ourselves thought when we were thinking about this problem. What if these agents don't stop talking to each other, right? It's going to be a disaster. So we have taken care of all that. Oh yeah, absolutely. I mean, I think that's the first thing that when me and Srini and our folks were talking about it, how do we know that these bots should stop talking to each other? So we have taken care, and that's where and we have that specific scenarios, and we know that that scenario is very typically scoped as well. Yeah. So we can take one last question. Okay, what is the most important irreplaceable role for a human tester in the new agent-to-agent testing model?
Yeah, it is. I mean, we asked this question ourselves as well. Where does humans come in place? So that's when we have given an option to add our own scenarios. Go back and validate whether the level of hallucination from the matrices that we have generated. So does it requires humans to go back and tune? It could be a prompt tuning, it could be the data tuning for the agent under test, and then come back and add more validation criteria, for example, right? So, and probably add relevant test data set, which could also help tune the agent to generate appropriate tests and talk to the agent under test, and then relevant matrices generated out of it. So humans are eventually there, and it is, I mean, the humans are irreplaceable, whether how many ever agents in it scenarios for us. That's we value it. That's when we kept validation at human level as well. We feel there is a lot of importance more than ever now. So not just scenarios that it has created, humans can feedback the knowledge back to the agent so that agent can generate more relevantly in the next iterations as
Yeah,
possible.
yeah.
Yes.
Because eventually there could be certain things that once it marks as a fail for you and for us as human, but knowing our systems a bit better, there could be cases where you might feel this is not a bug, see, so you could still come into play, let it tell that this is not a bug. And so there are multiple areas where the human definitely comes into the loop.
For example, configuring the thresholds.
Yeah, absolutely. I really would love to take some more questions, and I'm just scrolling through. There's like amazing questions, and probably the questions itself can turn out to be another session for us. So definitely we're gonna answer these questions offline. So we're gonna take this up. We don't. I mean, we're just running over 1 minute now. So thank you so much, folks. Staying around, and hope you guys enjoyed this session with us. And if you're interested, like I said, so sign up for the
Join for the
beta. So
beta.
you see the link down there, and we would connect with you. And have a great day. Enjoy rest of the conference, folks.
Thank
Bye-bye.
you again for joining.
Thank you. Bye-bye.